came up with this tabless architecture that maybe you've heard about, that basically removes the thermal problem from the equation and allows us to go to the absolute lowest cost form factor and the simplest manufacturing process. And this is what we mean when we talk about tabless. It's kind of a beautiful thing.
Yeah, that's what these T-shirts mean, but it's very esoteric. It's like nobody could figure it out. But
yeah, we basically took the existing foils, laser patterned them, and enabled dozens of connections into the active material through this shingled spiral you can see, with simpler manufacturing, fewer parts, 50 millimeter versus 250 millimeter electrical path length, which is how we get all the thermal benefits.
Yeah, this is important to appreciate. Like basically the distance that electron has to travel, is just much less. So you actually have a shorter path length in a large tabless cell than you have in the smaller cell with tabs. This is a big deal. So even though the cell is bigger, it actually has more power. The power to weight ratio is actually better than the smaller cell with tabs. This is, again, like this is quite hard to do. So it's nobody's done it before. And it really took a tremendous amount of effort within Tesla engineering to figure out how do we make a freaking tabless cell and have it actually work and then connect that to the top cap. And it's there's a whole bunch of things that we're keeping a little secret sauce here that we're not telling everything. But
sometimes what's elegant and simple is still hard, and it took us a lot of trials, but we're happy where we ended up.
Yeah, I mean everything's simple in recollection. After you simple, everything it's hard until it's discovered, and then it's simple. So anyway, but there's a lot of really cool things going on that enable tabless, and it's really due to a really great engineering team. Drew and the rest of the team have done amazing work in achieving this tabless construction. And it sounds, I think it may sort of sound a bit silly to some people, but this is like, for people that really know cells, this is a massive breakthrough.
For cylindricals to be able to get rid of the tabs dramatically simplifies winding and coating.
Yeah.
And has an awesome thermal and performance benefit.
Yeah, that's just to elaborate on that a bit. It's like when the cell is going through the system, it has to keep stopping where all the tabs are.
Yes.
So you can't do continuous motion production if you have tabs. You have to keep stopping, and then there's a rate at which you can start and stop and accelerate again, and it really slows down the rate of production. And then sometimes you get the tabs wrong, and you also lose a little bit of active area. It's really a huge pain in the ass to have tabs from a production standpoint.
Yes. And so when we put it all together and go to our new 80 millimeter length, 4680, we call this new cell design, we get 5 times the energy with 6 times the power and enable 16% range increase just form factor alone.
Yeah, so when these, yeah, it's pretty great. And just to clarify that when we see these plus 16% or whatever the percentage range increases, these are the amounts due just to that particular innovation.
Yes.
So we'll list a whole bunch of innovations, and then when you add them up, you get a total improvement in energy density and cost. But these numbers are what refer to just this thing.
Yeah, and I want to stress, this is not just a concept or a rendering. We are starting to ramp up manufacturing of these cells at our pilot 10 gigawatt hour production facility just around the corner.
Yeah. So, yeah. It's a video of some of what's going on in the plant. Now, I mean, to be clear, it will take about a year to reach the 10 gigawatt hour capacity.